This might be the most essential machining topic that we have ever covered. These drill indexes and the charts that decode them are the backbone of every job shop. And understanding how these tools work is a prerequisite for more advanced machining. We'll look at what sets these drill bits apart and why it might be time we updated our drill charts in this Haas tip of the day. This is a twist drill. Well, one very special version of a twist drill. It's part of a set of drills known as a drill index. And these combined drill indexes represent a drill numbering system that we learn young and continue to make use of throughout our career. That's what this video is about, the drill numbering system that all of our hole making revolves around. This is an index. No, this, my index finger, my pointer finger. In Latin, index literally means forefinger or pointer. When we go to an index at the back of a book, it points us to the pages we are looking for. Index cards guide us to the information we need, keeping everything organized. And when we go to a drill index, we are pointed right to the drill that we are looking for, which is much better than the old system. Here in the United States, the first twist drills were patented around 1861. And if we had a drill index at that time, it would have only come in fractional inch sizes, in 1/64 inch increments. Now for small machine screws, like these guys, these fractional drill bits just didn't work. The gaps between drills, that 1/64 of an inch, is bigger than some of the threads on these tiny screws. We needed a better system with smaller increments. So we looked to England. They already had a system in place for steel wire, a steel wire gauge system. We applied that to drill bits and came out with our numbered drills. And these increments were so tiny that they work perfect as tap drills for our tiny machine screws. Now, when wire is made, it typically starts life as a continuous casting from the foundry. This original wire rod is drawn through a series of dies, with its diameter shrinking as it passes through each die. If the wire ran through one die, it would be called a number 1 at, say, 0.228 inches in diameter, like we show on our drill chart. 2 dies, 0.221 inches, and so on. A number 7 drill would, as the story goes, have been drawn through 7 dies before reaching its 201 diameter. Now there's a lot of truth to this story, but also a lot of fiction. As a machinist, you might really want to understand the deep meaning behind all these numbers, this entire system. And I think that you are now old enough to hear the truth. This entire system is almost entirely arbitrary. Drill and wire gauge sizes are the Wild West of the machining world. Here, check out this excerpt from this 1914 edition of the Machinery's Handbook. The differences in the gauges for small diameter twist drills and steel wire are a constant source of trouble to those who have to deal with drills and steel wire. They were having problems since day one. Gauge numbers mean nothing except if the name of the gauge employed is specified. Some drill manufacturers are discouraging the use of gauge sizes and are asking that the sizes of drills ordered be denoted in decimals of an inch. They were having such a big problem back then that they were giving up on the drill numbers. A number 7 drill might measure 0.201 inches from one manufacturer and 0.188 inches from another manufacturer. The entire ship was sinking. Look at this. The Stubbs steel wire gauge is used for measuring steel wire and drill rod, but is not used as much in this country at the present time as in the past. This is craziness. Even the American Machinist Handbook from that same year, 1914, deals with this. They said that the different manufacturers of twist drills were off from the Stubbs wire gauge by as much as 1/2 thou to 4 thousandths of an inch. Their values were all over the place. Eventually, things were standardized. We see these variances all over the manufacturing world anytime the term gauge is used. Here, check this out. Here we have a couple pieces of sheet metal. Both are 22 gauge, but the aluminum sheet is actually thinner at 25 thousandths of an inch thick. The steel measures 0.0299 inches. That's not the strange part, but here's the point I want to make. I'm going to use a 7 gauge as an example here. This tool is used to measure sheet metal. If we look at a number 7 on this particular gauge, it would measure 0.1875 inches for sheet metal. This tool is used to measure wire. It's the AWG American wire gauge. A number 7 wire gauge would measure 0.1443 inches. While our drills that we were looking at earlier have a number 7 gauge drill, and that measures 0.201 inches. So 3 different gauge systems, 3 completely different diameters for the number 7. And we know this just innately if we've ever been around shotguns. I have these balls on the table because they represent shotgun gauges. If this ball were made of lead, it would take 1 ball at this diameter to weigh 1 pound. So the barrel this fits in would be considered a 1 gauge. And they actually have shotguns that size. They're called punt guns. Google it. 3 balls of this diameter would add up to 1 pound if this was made out of lead. So this would be a 3 gauge barrel diameter. For this guy, it would take 12 lead balls of this size. It'd be a 12 gauge shotgun. This guy down here is about a 22 gauge shotgun. It would require 22 balls of this size. And this guy right here is just under a 410, which actually has nothing to do with the gauge system. That's 0.410 inches. So shotgun gauge is different than wire gauge, is different than sheet metal gauge, which is different than drill gauge. A comment on another video that we made sums things up perfectly. They said that the great thing about standards is that there are so many of them to choose from. Now, our gauge drill numbers, diameter-wise, basically start at 0 and work their way up to a number 1 drill, which is at 0.228 inches in diameter. That's all there is. That's all there will ever be with these numbered drills. And that wasn't good enough. We had to add more drills to add more precision in larger sizes. And so what they did, because we ran out of numbers, is they created letter gauge drills. Still gauge drills, but these guys run from A to Z. Number drills, these guys go up to 0.228 inches, and our letter drills start with A at 0.234 inches and go all the way to Z, which is at 0.413 inches. And they take up the same column on our drill chart because they never overlap. And if we plot these gauge drill sizes, we can see that they don't follow a discernible pattern, which means that the only way we can know what decimal size one of these drills is by looking it up on a chart like this one. By the 1930s, in the United States, this was our drilling system. We started out with fractional drills, added the wire gauge drills. This is what we used. Now, I can almost hear the groans of machinists from all over the metric world right now, just looking at our system and saying, why? And in the words of Tommy Lee Jones,
if you have something to say, right now is the perfect time to keep it to yourself.
No, go ahead. Leave us your comments. I know they're coming. I will read them all. Looking forward to it. But it is not the 1950s anymore. We need more than this, even here in the United States, just to make good parts. And we're going to prove it to you. That's why we created this new drill chart that, and I'm sure you saw this coming, makes use of metric drill bits. We've made a lot of videos on cut taps, and more recently we made one on form taps, so check it out. When we revisited our drill and tap charts, we found that many of the charts out there were very outdated. Some of them are dating back 100 years to some of these original charts. One example is a 9/16 tap. This chart recommends a 33/64 inch drill. Now, the problem here is that a 33/64 drill is 0.5156 inches in diameter, which is already outside the minor diameter tolerance range of 502 to 515, given for this size in the standards. So how do we fix this? Again, we added metric drills to our set. On this chart, 9/16 18, we list a 13 millimeter drill for a cut tap, which measures 0.5118 inches, which is smack dab in the middle of our tolerance. And there are other examples of this as well. If we go to this older chart, for a 5/8 18, it's recommending a 37/64 drill. Newer charts might recommend a 9/16. Now the Machinery's Handbook calls out 0.565 to 0.578 for a 2B, or 0.565 to 0.573 for a 3B fit for a 5/8 18 tap hole. Using a 9/16 drill would put us 2.5 thou undersize, and using a 37/64 drill puts us over by 1/10 of a thou for a class 2B thread, and over by more than 5 thou for a 3B thread. And that's with no runout. We recommend a 14.5 millimeter drill, which measures 0.5709, which is right in the middle of our tolerance. 50 years ago, many tap drill charts took runout into account. They expected a drill to have as much as 0.04 of an inch or 100 micron of runout. Now, with today's modern machine tools and modern tooling, like these drills here have 135-degree split point tips on them. That pretty much cut on size if we're using a good holder. And our chart reflects that. We've taken that into account. And you can download this chart by following the link in the description. You can download it as a PDF to view or print. I guess that's it. Thanks for letting us be a part of your success and for watching this Haas Tip of the Day. While I've still got you here, I wanted to talk metrology just for a second. Leave a comment and let us know what other types of gauge systems you have seen out there. I'm just interested, and I thought it'd be a fun conversation to start. There are all kinds of ancient measurement systems out there. Even the inch, which is now based on the metric system. 1 inch is 25.4 millimeters, and the millimeter is based on the meter, which is based on the speed of light. Long system. At one time, the inch was based on barley corns. King Edward II said that there were 3 barley corns in 1 inch. And our shoe sizes today in the US and the UK are based on those same barley corns, with the distance between each shoe size being 1 barley corn, or 1/3 of an inch. So there's all kinds of ancient systems out there that are still in use today. Let us know about the ones that you've heard about in the comments. That's it. Have a great week.